Okay, so I got asked by someone in class to go over a problem from the test review homework regarding finding the rational and irrational zeros of a polynomial. So I'm going to do this using the synthetic division method that we went over in class. So this is the problem in question, and it popped up in several parts, and the first part was to find all of the possible rational zeros using the PQ theorem. So the PQ theorem, P over Q, P comes from the constant term, and Q comes from the leading coefficient. So what we end up with here is all the factors of 30, so 1, 2, 3, 5, 6, 10, 15, and 30, plus and minus, over all the factors of 5, which is 1 and 5, again, plus and minus. Alright, so all possible zeros you're going to get just by making the ratios. So 1 over 1, we'll do everything over 1 first. So 1 over 1, 2 over 1, 3 over 1, 5 over 1, 6 over 1, 10 over 1, 15 over 1, and 30 over 1, plus and minus. And then each of those over 5, so 1 over 5, 2 over 5, 3 over 5, 5 over 5 is 1, so we already have that, 6 over 5, 10 over 5 is 2, we already have that, 15 over 5 is 3, we already have that, and 30 over 5 is 6, we already have that. So these are all the possible factors. Now, to determine which one to start with, you're going to go to your calculator. And I'm just going to pull my calculator into frame here. I've already graphed this. Alright, so we have... yeah, I didn't think it would do that. Alright, trust me, I already graphed this, and it looks like the graph is crossing at -2. That's an easy one to spot. So I'm going to start with -2 as my first rational zero. Alright, so we're going to say that x equals -2 is my first rational zero. Now, I'm going to do this by synthetic division. If you want to do it by long division, you can. Just separate this off here so I can get some room to work. Alright, so for the synthetic division, you're going to write the coefficients down. 5, -18, -41, and 30. Alright, and then the root, which is -2. Put down a 0. Alright, 5 and 0 is 5. -2 times 5 is -10. 18, -18 and -10 is -28. -2 times -28 is -56. I'm sorry, +56. Alright, so that's going to be 15. -2 times 15 is -30. And I get the 0 there that I need to indicate that that was actually a factor. Okay, so determined one rational zero, and I've taken my third degree polynomial and I have now reduced it down to a second degree polynomial. Alright, now you could try to find another rational zero on the calculator and do this again, but since this is a quadratic, I'm just going to use the quadratic formula. Alright, so x is going to equal -b, so that's going to be 28, plus or minus the square root of 28 squared minus 4 times 5 times negative 15 all over 2 times 5. Alright, now if we work out in the middle there what 28 squared minus 4 times 5 times negative 5 is 884. Alright, so this is going to be 28 plus or minus the square root of 884 over 10, and the square root of 884 is not a rational number because this is a plus 15. Sorry. Alright, let's fix that. That is a plus 15. So that's going to make that 28 squared minus 4 times 5 times 15. 484, that's better. Alright, so I'm just going to cheat here. Alright, 484. There's no good way for me to do that. No, there's no good way for me to do that. Alright, let's just rewrite this whole term here. 28 plus or minus the square root of 484 over 10. Alright, so this is going to be the square root of 484 is 22. Good, that worked. 28 plus or minus 22 over 10. Alright, so what this means is I'm going to have two more rational roots. There won't be any irrational roots here. Alright, so I do 28 plus 22 over 10, and I do 28 minus 22 over 10. So 28 plus 22 over 10 is 5. Alright, so this one equals 5. This one is not going to come out to be, I don't think, a whole number. It's going to be a rational number, so that's going to be 6 over 10. Which is going to be 3/5. Alright, so we end up with x equals negative 2, x equals 5, and x equals 3/5 as rational roots, and then the third part of the question asks about any irrational roots, and that answer is going to be that there are none. Alright, so hopefully this helps, and keep the questions coming.